Okay, let's dive right in. Ever stop to think about what your phone, your car, and even your soda can all have in common? It's aluminum. But the journey of that metal, it doesn't start in some factory, it starts right here, with this reddish rock called bauxite. Today, we're going to follow its incredible path, from deep inside the earth all the way to the global market. You know, aluminum is one of the most common metals in our daily lives, but its origin story is way less known. The whole journey kicks off in a place you probably wouldn't expect, with a material you've likely never even heard of. And this is it. This simple-looking rock is the primary source for pretty much all of the world's aluminum. It's not a metal itself, nope. It's a sedimentary rock that's super rich in aluminum oxides, and its story is what we're focused on today. So, before we can even get to that shiny metal we all know and use, we have to understand the mineral deposit itself and the specific geology that creates it in the first place. Right, so bauxite isn't just scattered around randomly. It forms in these very specific deposits, usually near the Earth's surface. Just try to picture it. Millions and millions of years of intense tropical weather. We're talking relentless rain and heat, washing away basically everything else, leaving behind this concentrated layer of aluminum-rich material. Okay, now that we know what it is, let's look at the next part of the process, the absolutely massive industrial effort it takes to find these deposits and then get the bauxite out of the ground. And this slide breaks down those four key stages perfectly. It all starts with geologists exploring, basically hunting for the right spot. Then, they drill down to take core samples to make sure the ore's quality is good enough. Once they get the green light, boom! They use explosives to loosen up the earth, clearing the way for massive excavators to come in and just scoop up all that raw bauxite. We are talking about a truly industrial-scale operation here, designed for one thing and one thing only, moving millions of tons of rock as efficiently as humanly possible. These haul trucks are the size of small houses, seriously, and the conveyor systems can stretch on for miles, acting like the arteries of the entire mining operation. But once that rock is finally out of the ground, the work has really just begun. Now the whole focus shifts from brute force to quality control. It's all about preparing the ore for its long journey ahead. This is the essential first step in processing. Think of it like a giant industrial-strength coffee grinder. You're breaking these huge boulders down into a consistent size, which makes it so much easier to handle, to analyze, and to transport in all the next stages. Now, I know what you're thinking. It's just a big pile of rocks, right? But what's really interesting here is how this simple stockpile is actually a critical piece of logistics. It's a buffer. It makes sure that the port or the processing plant has a continuous supply, even if there's a temporary shutdown back at the mine. It basically smooths out the entire supply chain. Look, ensuring a steady supply is one thing, but that supply has to be the right quality. And this brings us to a huge question for the whole industry. How do you know if the bauxite is any good? Because, let me tell you, not all ore is created equal. Its value really comes down to three key things: its grade, its impurities, and its moisture content. And this chart just makes it crystal clear. High-grade ore has more of what you want, that's the aluminum oxide, and less of what you don't, like silica and extra water. It's pretty straightforward. The higher the grade, the more aluminum you can get from each ton, which makes it much, much more profitable to process. And this chart really drives that point home. I mean, look at this. Even in high-grade ore, a huge chunk of it isn't the valuable aluminum oxide. That iron oxide gives it that classic reddish color. But it's the silica that's the real problem child here. It's abrasive, and it can cause all sorts of expensive problems during the refining process, which makes that ore a whole lot less valuable. So, once it's been mined and crushed and graded, the bauxite is finally ready to leave its home country and enter the vast global commodity market. Bauxite is a classic bulk commodity. It gets moved by train or truck to a dedicated port, where it's then loaded onto these enormous ships destined for refineries thousands of miles away. Every single one of these steps is a link in a super complex transportation network that feeds the world's constant demand for aluminum. Now, this slide highlights a really key distinction in the world of commodities. A resource is the total estimated amount of bauxite on the planet, but a reserve? That's the slice of the pie that's actually profitable to mine, right now with current technology and at current prices. The reserves are what truly fuel today's global supply. And this really brings us to the biggest challenge for the future. I mean, from rehabilitating the land after the mining is done to reducing the carbon footprint of all that global shipping, This whole journey is incredibly energy intensive. The industry is exploring everything from more efficient refining to alternative energy, but making this process truly sustainable, that is the defining question for the future of aluminum. And it's a journey that is far from over.